So can you solve this exponential equation? Now it looks complex and hard, but it's actually very simple. Very, very simple. Now make sure you watch to the end to learn a very new strategy. Now the strategy we're going to be using here is called the UniFiX strategy. UniFiX strategy. That's to unify and to fix. It's a strategy that helps us to approach questions whereby the variables are of different forms. Now that UniFiX strategy has 3 steps basically. The first step, very simple, is to identify the given variables, and the second one is to try to transform the variables so that they have the same form. Then we simplify and we get our answer. Very, very simple. Now let's identify the variables on the board. That's variable x, that's len x. Now when we see this question on the board, we'll see that len x here is a power while len x here is not a power. So we have to unify them. So let's transform this to a power so as to make the equation to be easier to solve. Now, how do we now transform this to a power? How? Very, very simple. We're going to use this basic law of logarithm that says that a raised to the power log b base a will give us what? B. That is when this and this are the same, it cancels out and give you the number here. As simple as that. Okay, so how do we apply this in our question? Let's go. So let's rewrite this as 2 raised to the power len x plus. Now, before we continue, let me extend that law to len, because we're not going to be using a natural logarithm here. We're going to be using Neptunian logarithm. So now using Neptunian logarithm, when you have e raised to the power len y, for an example, will give us y. E cancels len, give us y. Why? Because len is a log that has a base of e. We can write this as e raised to the power log y base e. So the log e cancels this and we have y. Are you following? So for natural logarithm, we're going to be having len, not log. Okay, still the same thing but different base. So len x here now, we're going to rewrite it as e raised to the power len x raised to the power len 2 equals to 4, because e cancels len to give us len x. So I haven't done anything strange. That's a very, very brilliant mathematical idea. Now, what do you do next from here? Let's try to simplify this. This is law of indices. This multiplies the power. So we have 2 raised to the power len x plus e raised to the power. Len 2 multiplies this power to give us len x times len 2, which is equals to what? 4. Yes, we are getting closer. We are already getting closer to unify our variables. Now we have len x as a power. In fact, not just len x, we will have len x, len x. That's a very, very massive improvement. Now we are almost done with unifying our variable. But when we look at this here now, there's now one problem. What we have done, there's a consequence for it. What is that consequence? We have now introduced len x as a multiplier of our variable. There is no, sorry, we now have len 2 as a multiplier of our variable, but here there is no len 2. Don't forget, the variables of x must exactly be the same. So what do we do here? We don't have any choice than to introduce len 2 in this part so as to make the variables look exactly the same. Now, how do we bring len 2 as a power? Still going to use the same law. Okay, we're going to use the same law. So instead of 2, we have e raised to the power len 2, because e cancels len and gives us 2, so it's still the same thing. So here, instead of 2, we are going to have e raised to the power len 2 len x plus e raised to the power len x times len 2 equals 4. Now let us expand the bracket. We have e raised to the power len 2 times len x plus e raised to the power. Now, because of this multiplication, we can write n1 first. Okay, so we can write this as len 2 times len x equals 4. Yes, you can see that we have finally transform the other form of the variable and make them look exactly the same. Look at the power here. We have len 2 len x, len 2 len x. That's very good. Now we're done with step 2. What was that? Step 3 is to simplify this exponential equation. Now, how do you simplify the exponential equation? Look at these two. They are exactly the same. E raised to the power len 2 len x, e raised to the power len 2 len x. They are the same. So because they are the same, when we add them together, we have 2 e raised to the power len 2 times len x equals 4. This is just like saying we have y plus y equals 2y. because they're exactly the same. So that's why we have two of this. So what we do next is divide both sides by 2, okay? Divide by 2, then we have e raised to power ln 2 times ln x equals to 4 divided by 2 will give us what? 2. Now, what do we now do from here? Because of this is an exponential equation now, we don't like having power. So we have to get rid of the power. How can we get rid of the power? We can do it in two ways. It's either we take ln of both sides, but I don't want that. I want us to continue using that law that I've been using. We'll express 2 also as the power of e. So instead of 2 now, we'll be having e raised to power ln 2 times ln x equals to e raised to power ln 2. Don't forget, e cancels ln to give us 2. Now, we now have equivalence. So let's e cancels e. So we're left with ln 2 times ln x equals to ln 2. We are getting close. Now we already have a kind of a linear equation. So when we look at this left hand side, we have ln 2. We have ln 2 here. Ln 2 cancels ln 2. We have ln 2 cancels ln 2. So we are left with ln x equals 1. Ln x equals what? 1. And don't forget, ln is a logarithm that has a base of e. And according to that, the law of logarithm, whenever I want to express a logarithm as a power, this e raised to power 1 will give us this here. Okay, that's log ab equals x. So to express this in index form, we have b raised to power x equals to what? A. So that's what we're going to do here. This one has a base of e. So e raised to power 1 will give us ln x. Are you following? Let's continue here. Now, I'd rather we flip this equation so as to make it look nicer. So we have ln x equals e. So what we have done here, we're going to do the same thing here also, because ln has a base of e. So e raised to power e will give us what? X. I want to express this logarithm in form of indices. So we're going to have e raised to power e equals x. What? We are done. Therefore, x equals e raised to power e. Very, very simple. Our answer looks strange, but it's actually very, very simple. Please don't forget to subscribe. It's very, very important. If you want to see more content like this, as a way of supporting me, please try to hit the subscribe button. And so that we have solved the question using the UniFiX strategy. Number 1, identify the variables. Number 2, transform the variables, make them look exactly the same. Then number 3, simplify the equation using logarithm and using the algebra. That's that. Thank you very much for watching, and don't forget to subscribe. Bye-bye.